Hello. So in this video, I'm going to show you real data. And in real data, usually you have more complicated, and especially you have multiple variables at the same time. So we will study how we can understand the structure underlying the data. So the data I prepared today is NLSY, National Longitudinal Survey of Youth 97. So let's have a look. This is Excel file, and we have multiple variables, several variables like gender, birth year, race, region, where region of residence, education, marital status, employment status, health insurance coverage. So you can imagine it is a survey data, and the survey goes like this. A random person is chosen, and the respondent, the participant, survey participant was asked how many questions? 1, 2, 3, 4, 5, 6, 7, 8 questions. So the questionnaire includes 8 questions. And the first question is, what is your gender? And the answer options are male or female. And the second question is, what's your birth year? And the options are years and race, region, like that. Actually, the original data has more than 8 variables. Maybe it may include more than 100 variables, because asking like a survey is so expensive, so it tries to usually survey tries to ask as many questions as possible. So original data has many more variables, but I chose some key variables to show you. Okay, so it is a survey, and so that is the first person was female and was born in 81 and non-black, non-Hispanic, and lives in Northeast, and finished high school, never married and employed, but has no health insurance. And a second person's profile goes like this, and third person, fourth, like that. So let's see how many people are recorded in here. You see, there are more than 7,100 survey respondents. The survey asked questions from to like 7,100 people, right? And so this is like actual data, much larger, and not as simple as coin toss or dice. So this is an example. This is the full name, U.S. National Longitudinal Study of Youth. So then, just in case if you are interested in this data and if you are willing to do some research based on this data, let me explain. So it is a longitudinal study. That longitudinal means the same people are interviewed every year or every other year over time. So the first year the survey was conducted was 1997, and those who participated in the survey were interviewed every year since then. And the data was from 2006 survey, approximately 9 years after the first survey, right? So in this data, the population was designed to be the people, like the people who live in US and who were born between 1980 and 1984. At the time, this cohort was youth. So we call the data as like study of youth. So the population is restricted to be younger people, this generation. And after I remove missing values and those who did not answer questions, I got 71 and 55 observations. That's excuse me. That's what you see. And then let's imagine what is the underlying experiment. The underlying experiment is to randomly choose a person that satisfies the population criteria, right? So we restrict our study subjects to a certain generation. So choose randomly out of those population. And then ask 8 questions. And then the point here is, what's confusing here is, even if you observe 8 outcomes, 8 observations from one person, but one person is only one experiment. Even if it generates 8 entries, still that is one repetition, right? Because one repetition is one person. Choosing one person is one experiment. So, and one experiment generates 8 observations. That is, the sample size, how many questions you have does not affect your sample size. Sample size is the number of repetitions of this randomization, randomly choosing a survey person, right? So that's what you have to understand from this data. You have to understand what is the experiment and what is the experimental unit, observational unit. In this case, one experiment is one person, so observational unit is one person, and one person is one row from the data, right? And each column is called a variable. So gender is one variable, birth year is another variable. Like that, we call variable. So you can imagine one question generates one variable. It's about like one topic. Right, so and what I'm going to show you now is more practical demonstration. So suppose you have data. As I said, this data is just a bunch of numbers. You don't know what's going on. Say, for example, we are interested in health insurance coverage. I'm curious how many people do not have health insurance. But if I give you this number, like show you a number like this, outcome like this, it's hard to see. No, yes, yes, no, no, yes, yes. It looks like there are a little more yes than no's, but I don't know. So it's not, you need to summarize the data. You cannot present the data as it is. So then what you can do here is, you need to use pivot table. Excuse me. Where is the pivot table? So here it is. Insert pivot table. So you don't need to choose the variable. Just you click Insert tab and click Tables and choose pivot table. And then I'll just click OK. Now you don't need to worry about that at the moment. So by the way, this is purely very introductory demonstration to pivot table, because many of you don't know this function at all. So this is a very useful function built in Excel. So I hope you understand this. So you see options here. I am going to choose health insurance coverage. And then if you click that, it automatically goes to rows. But then each row, one row, is defined by the outcome for this variable, right? So, and now the problem here is you defined row, but there is no content. the values need to be defined like this. So if you click and drag to this column, this panel value, then it shows count. So this is frequency. It is a summary. Out of 7,154 observations, 2,410 people do not have health insurance. So this is a powerful summary. It better explains, better describes what is going on in this data. And then, okay, it is good. It is a count, but we want to change this outcome, this presentation into percentage, into probability. To do that, like, you have to change the option. So value in the value is, I did not change the value option at all, but you have to change value field setting here. Click this, and then show value as, change to this tab, show value as percentage of grand total. Okay? Then it gives you percentage. So approximately 34% of people do not have health insurance, right? So this is a very useful function in Excel. So try to try to do what I have done and see, like, if you're good at Excel, you don't need to worry about that. But just in case, if you have not used this function before, I strongly recommend you to try this and get more familiar with Excel, because you don't need to know the structure of probability for your career in your like on your job. Like, no one asks you about what is experiment, what's the definition of event, but you need to do this. You need to do Excel on your job. So this is more useful part. So please try that. And this is exactly what you see here. And this is how you make a probability distribution table using pivot table function on command on Excel. Okay, let me stop it here. Let me stop it here. In the next video, we will consider two variables at the same time. So handling only one variable, health insurance, is simple. So in the next video, I'll show you what happens when you are interested in multiple variables. See you later.